Okay, so from this video onwards, we are going to start our discussion around recurrent neural network or RNNs. So far in this deep learning tutorial, we started with ANNs, that stands for Artificial Neural Network. Then we moved to CNNs, which is an architecture which is capable of processing image data. And from this video onwards, for next 4 to 5 videos, we are going to shift our focus to RNN. And whatever we have learned about ANNs, it was applicable for tabular data, if you remember. So basically the data set that comes in the form of rows and columns like this. Okay. And then we studied about convolutional neural network, which is a deep learning architecture that works really well on image data. And we have covered a lot of things in CNNs, starting from absolutely basic to the entire forward and backward propagation. And talking about RNNs, it is a type of a sequential model. So basically it is designed in such a way that it works with sequential data. Now some of you will have some difficulty understanding that what exactly is a sequential data. So let's try to understand that first. In very simplified terms, sequential data is a type of data set where each and every data point, okay, will have relation with the previous data point. And I will also give you the example of it. But first, let's try to understand that how tabular and image data are not an example of a sequential data. Talking about a tabular data first, let's say that these are the features x1, then x2, then x3, and then we have the target column, which is y. Then each and every data point that can be indicated by these indexes, okay, let's say 1, 2, and 3. These will be independent of each other. What I mean to say that let's say x1 is the number of bedroom, x2 is the area of house, and x3 is the number of bathrooms you have. Depending on these three features, you can predict the price of the house. Okay, so these values will have the contribution towards predicting the price of the house here. However, this price will not be dependent anyhow to the information on the previous data point, which means these features or the price over here, it has no relation with that. So each and every row, the information on each and every row is independent of the information on the previous row. So we have understood that this one is not a suitable example of a sequential data. Similarly, if we talk about an image, let's say an image of 3 by 3 like this. Okay, so these are pixel values, and we have studied this thing in a lot of details in the CNN lectures. And this type of data is called a grid structure data, not a sequential data, because again the value on this pixel has no relation with the value on the previous pixel, right? So obviously these two are not a considerable example of a sequential data. Now let's try to have a look on a couple of examples of a sequential data. First example could be time series data. So let's say that you have a data like this, okay, where you have the stock price information of day 1, day 2, day 3, or let's say day 4 here. Okay, and let's say the price on day 1 was here, on day 2 it was here, on day 3 again it was here, and on day 4 it was here. So the information or the price on each and every data point in this case over here is definitely related to the information on the previous data point. If you have ever worked with a time series data or stock price prediction project, then you will be able to understand what I'm saying here. So the data will look like this, okay, and this is a very perfect example of a sequential data. Second could be text. So let's assume a sentence like this. Let's say boy is tall, okay, then next sentence is he likes to run. Yeah, right. So this entire statement has a meaning because all these words are in a sequence. Okay, and if you try to shuffle all the words on this sentence here and there, then it is going to lose its meaning, right? So obviously text is another good example of a sequential data because the sequence of each and every word is very important in order to preserve the semantic meaning of the statement. And similarly, other type of examples could be speech or also DNAs. And for these type of data, which are sequential data, ANNs or CNNs won't be able to perform that good. And here comes the need of a sequential model, and this is why we learn about RNNs, which is a special type of architecture within the field of deep learning that is specifically used to process sequential data. And in this lecture, we are only taking a very high level overview. So we are not going to dive deeper into the architecture of a recurrent neural network, or we are not going to learn about the forward or backward propagation in this model. Because obviously I have planned dedicated videos to cover these topics. This particular video is just to get you a bit comfortable with the topic so that you can have a high level understanding that why do we need RNN, or why do we have this concept within the topic of deep learning. The next thing that I want to tell you is that there will be different types of RNN. There will be an RNN called as many-to-one. Another famous type is one-to-many, and the next one is many-to-many. So although I have planned to create a video on this topic on types of RNNs, but still I would like to go ahead and give you a few understandable examples so that these types of RNNs can make some sense to you. So a good example of many-to-many type could be Google's translation, where you enter a sentence and then Google translates it to a different language. So this sentence, which is coming as an input from you, can have many words, right? Like he is a tall boy or she is a bright student, something like that. And also the output that you will have over here will also have multiple words, at least in most of the cases. And if you have ever used Google Translation, that is also implementing a many-to-many type of RNN in the background. Not exactly RNN, but an architecture which is based on the concept of RNN. Moving ahead, the example of one-to-many could be an image captioning model. So these are special types of generative models that can take an image as an input, and then depending on the objects that you have within the image, let's say you can have a person or you can have a car like this, okay, the model will have the tendency to create caption for this image. So again, in the input you have only one thing, which is this particular image, and in the output you have multiple words within the caption. And this is an example of one-to-many type of RNN. And then we have many-to-one type of RNN. A very perfect example of this type of RNN would be a model that can do review analysis. Okay, so if you have ever worked on an NLP project where the problem statement is around review analysis, then you will be able to understand what I'm saying. So basically, with this type of model, in the input you will provide many words, okay, like the food was really good in the restaurant, the staff behavior was also very nice. And depending on this type of review that has multiple words or many words, the model will come up with an output that will have only one word, like good, average or bad. So I hope that you were able to gain a very basic understanding around these variations of RNN types. Now next thing that I want to discuss with you is around the vectorization techniques when you are working with a recurrent neural network. So the thing is, doesn't matter if you are working with ANN or CNN or RNN, and the data that you have could be a tabular data, image data or a sequential data. And talking about a sequential data, we have already understood that it could be text as well. However, regardless of these three types, you cannot ignore the fact that computers will not understand anything else except numbers, because down the line it is converting everything between 0 or 1. That's all that a computer understands. And in terms of RNNs, when you are working with text data, then obviously you need to have some sort of understanding around few techniques to convert these words into numbers. So let's say that you are working with RNN and you have a feature X and a target column Y. And in feature X, you have text data. Let's say something like this. He is tall boy. Okay. And doing some analysis on this feature or on this text, you have some value on the target column, either 1 or 0. Okay, so for the time being, let's consider it as 1. You should have some understanding around how to convert this text data into numbers or computer understandable integers. So let me give you an example of one of the very basic and simple way of converting words into numbers, or should I say an example of very basic vectorization technique. So let's say first we want to convert this particular word into vectors. Okay, so since we have 4 words within this statement, we are going to have a vector that looks like this: 1 0 0 0. Okay, this particular vector is representing the first word he. Then let's convert this one. So we will say 0, then 1, then 0 0. Going ahead, next we will say 0, 0, 1, 0. And finally, for the last word, we can convert it like 0, 0, 0 and 1. So obviously it is very easy to understand that at the respective position of each and every word, we are keeping the vector value 1 and rest are 0. And since we have already discussed that RNNs are sequential model, which means it will not take this entire statement as an input at a time. It is going to take each and every word sequence by sequence in order to understand the pattern to come up with a suitable output. So let me explain you what I'm trying to say here. Let's assume that this is the RNN model. Okay. So for the time being, I am keeping this as a simple square box because obviously we have not studied the architecture of RNN so far. And let's say that this is how the input is going in and we have the output coming from here. And let's say we want to pass this particular data point, which is this entire statement, to our model. Then first of all, each and every word will be vectorized into numbers. A very simple and understandable vectorization technique could be this one. And then we take each vector at a time that will represent each and every word. We take this vector and we will feed it to the RNN network like this, one at a time. Once it is done, again we will take the vector of the next word and we will feed it to the model, and then this and this. However, that is not the point that I'm trying to make at this moment, okay? Because we are going to discuss this entire flow of forward and backward propagation in a different video. But my point is that before passing this data point or any statement to the RNN model, we need to use some sort of vectorization technique in order to convert text into numbers. And some of the frequently used vectorization techniques are following. So one is one-hot encoding, second is bag of words, third is TF IDF, and fourth one that is coming to my mind is word to vec. The vectorization techniques are not limited to this, but these are the most frequently used ones. And once I finish the deep learning playlist, then I'm going to create a dedicated playlist on NLP, and over there I will discuss all these techniques in details. So we will explore all of these ideas of converting texts into computer understandable numbers or integers. So for the time being, all you need to understand is that we need to use some sort of vectorization technique before we pass the text data to the RNN model. And with that being said, there is one more question that should be coming to your mind. Okay, so let me quickly erase all this first. And the thing is that you should definitely have a question in your mind that this specific problem of processing or dealing with sequential data like this that we are trying to solve with RNN, why cannot we use ANN for the same? It is understandable that CNNs are used only for grid structured data like images, but since we are already converting texts into vectors, then ANN should also be able to do the job for us, because ANNs are also very efficient in order to deal with numbers. And this question will be asked to you in interviews as well, that the problem you are trying to solve with RNN, why can't you use ANN for the same? So few valid reasons are as follows. When previously we were learning about ANNs, we studied that the structure looks something like this, where on each and every layer you will have perceptrons or neurons that will be connected or will have a dense network with each and every node on each and every layer, like this. Okay, then like this here. And also the number of perceptrons on each and every layer will be fixed. So for example, here we have 5 perceptrons on the input layer. 1, 2, 3, 4 and 5. However, when your data is a text document where you have thousands of records like this, okay, you cannot guarantee that within each and every record the number of words will be equal. In a given index, you can have 20 words, then possibly in the next row you may have 200 words as well. So this is the first problem that you will come across when working with ANNs instead of RNNs. Now let's quickly discuss a temporary workaround for this. Okay, let's say in your data set, the row or data point with maximum number of words is 300. Okay, then you can simply do one thing, that in the input layer over here, in the first input layer, you can set your number of perceptrons as 300, and then what can you do? You can apply padding. Okay, so you can take this particular vector which has only 4 numbers, which is 296 lesser than this 300 words. So you can do one thing, that by the end of this particular vector you can add 296 zeros. So it will look something like this. Previously you have a vector looking like this, and then you start adding so many zeros till the time you have in total 300 values within your vector. And you will have to do this for each and every vector representing each and every word within your data point. So if you try to go ahead with this particular temporary workaround, then this will also lead to issues like memory load and computational wastage, because this time your model is not processing small sized vectors, it is unnecessarily processing huge vectors like this. So this is the second issue. Third will be that even if you set the number of perceptrons on your input layer as the maximum number of words that you have within your dataset, okay, in that case, what will you do when you are using your model for prediction and the user is giving an input that has more than 300 words, let's say 350 words. In that case, again, your model will lag. And lastly, the biggest problem with RNN would be, while inputting your text data to the RNN model, it will lose the semantic meaning of the data due to disregarding the sequence. So I'll try to explain what I'm saying here. Let me make it slightly clear. Okay, previously we have discussed that if you're trying to input this data to your RNN model, okay, then you will input the data sequentially. First you will input this word, then this word, then this word, and then this word. And what is the reason for that? This statement is making some sense, or it has some meaning, because the words within this particular word is in a specified sequence. So if I tell you that he is tall boy, then you understand the meaning. But if I tell you that boy he tall is, then definitely it is not making any sense. And this is the core idea of sequential data. They need to be in a sequence in order to have some meaning. And this is why we use RNN, because we input these words or these vectors to the RNN model in a sequence. Similarly, the way we are reading the statement in a sequence, like he is tall boy, you will not read these words randomly like tall boy is he, right? However, if you are using ANN with the same data, okay, then the information on this particular data point, which means this entire vector starting from start to end, will be taken as an input entirely at a time when you are working with ANN. And by doing this, you are disregarding the sequence. And this is why the model loses the semantic meaning. So again, I will recap very quick. The top reasons why we cannot use, or we should not use, ANNs instead of RNNs when we are working with sequential data are as follows. The first is that text sentences comes in varying size and length, but number of perceptrons in your ANN architecture will be fixed. The second reason is, even if you are using a solution like padding, that will lead to computational wastage or memory load. Also, while testing the model for prediction, if the user is providing an input that has number of words more than number of perceptrons on the first layer or input layer, then again your model will not perform. And the last reason is, since you are disregarding the sequence of your data while providing the input to your ANN model, you end up losing the semantic meaning of the data. Okay, so these are few important pointers that you should keep in mind. And lastly, let's go ahead and finish this video by having a look on some interesting applications of RNN. So RNNs can be used for sentiment analysis, or similarly you can also use it for review analysis. Let's say you can create an application where the model or the application takes the review, and by analyzing the review it can classify itself if the review is good or bad. Another interesting application could be auto-completion, which is vastly implemented on applications like Google Keyboard that we use on our phones, and also on Gmail application as well. And similarly, based on the concept of RNNs, we have some advanced architectures which are being used in the field of LLMs or generative AI as well. The next interesting application could be Google Translation, where you provide an input to the Google Translation application in your language and you can get it translated in any language of your choice. Also things like time series forecasting. In fact, it can be used for stock price prediction as well. And the applications of RNN is not limited to this, but these are one of the most interesting concepts or problem statements that we can solve with RNNs. In the next video, we are going to discuss about the architecture of RNN, followed by the forward and backward propagation method in recurrent neural network. And if you found this particular video helpful, then please consider dropping a like below. Consider subscribing to the channel if you are new here. And I thank you very much for watching till the end. See you in the next video.